Now, there are two different ways that researchers go about actually collecting the data. That's observational studies and experiments. Observational studies are where you just collect information based on what you see, you measure things. There's no trying to control anything. Okay, and observational. So surveys, for example, are observational studies because you're just asking questions, just collecting the information. You're not trying to influence anyone. Okay? An experiment is where you give different treatments. Okay, you're trying to control something. You give different treatments, and then you measure the effects of those treatments. And so, an experiment could be something like I'm gonna plant some seeds, and some of the seeds that I plant, I'm gonna give them a certain amount of sunlight, and then others I'm gonna give a different amount. Okay, and I'm controlling the amount of sunlight, and that would be an experiment. And then I measure, how fast they grow or something. So. An experiment is where we are controlling something and then measuring outcomes. An observational study is we are just collecting information without having a hand in what's happening. Let's see if we can identify them. You test a new kitchen cleaner by buying a bottle and cleaning your kitchen. So you're trying to collect information about this new kitchen cleaner. And it doesn't say that we're trying to control any outcomes here. We just use it, see what happens. And so this is an observational study. Observational study. Okay, next, the weights of 30 randomly selected people are measured. We're not forcing them to go on certain diets or different exercise regimens. We're just measuring it, seeing what it is. So that is an observational study. Next, subjects are asked to do 20 jumping jacks, and then their heart rates are measured. So this is, we're doing a treatment, right? We are saying, do these jumping jacks, and then we're going to see what happens. And so that's an experiment. That is an experiment. Because we are doing something, we're forcing them to do something, and then seeing what effect that had. 20 coffee drinkers and 20 tea drinkers are given a concentration test. So here we're not making them do anything. We're not making them, change anything they're doing. We're not forcing people to drink coffee and some people to drink tea. We're just taking these people and then doing a test to see what we can observe. So this is an observational study. Observational study. Okay, next, a pharmaceutical company tests a new medicine for treating Alzheimer's disease by administering the drug to 50 elderly patients with recent diagnoses. Well, we are administering here a treatment. We're giving them something that they wouldn't normally do. Taking this new medicine. And so this is an experiment because we are controlling something and then measuring an outcome. Okay, next, a substitute teacher wants to know how students in the class did on their last test. Asks the 10 students sitting in the front row to state their latest test score. Obviously, this substitute teacher has no control over the students' test scores. And so this is an observational study. A gym tests out a new weight loss program by enlisting 30 volunteers to try out the program. So here, this is the gym is doing an experiment because they're controlling something. They have a new weight loss program and they have people that go through it to see what happens. And so this is an experiment. They're not just letting people do their own thing. They're giving a specific treatment. Next, a psychology researcher explores the effect of music on temperament by measuring people's temperament while listening to different types of music. And so this is where the researcher has the different types of music. and makes the people listen to the music and then sees what happens to their temperament. So this is an experiment. Because they're giving treatments and then measuring. Next, high school students are asked if they have consumed alcohol in the last 2 weeks. There's nothing done here to control what's happening with the high school students. It's just yes or no. Have you consumed alcohol in the last 2 weeks? So this is an observational study. Let's talk about some different aspects of some studies and experiments. One of these is confounding. And confounding is when we're looking at the effects that different variables have, but it's not possible to differentiate between two different variables and what effect that they have. And so some result happens and we're not sure what caused it. It could be, thing A or thing B. We don't know. That's what confounding is. So let's look at some examples of that. First, suppose middle school finds that their students are not scoring well on the state standardized math test. They decide to run an experiment to see if an alternate curriculum would improve scores. To run the test, they hire a math specialist to come in and teach a class using the new curriculum. To their delight, they see an improvement in test scores. So we see an improvement in test scores, and the question is, well, what caused it? And unfortunately, this middle school, the administrators obviously didn't take a statistics class or learn anything about statistics because they did not separate the possibilities here. There's an alternate curriculum and there's a math specialist teaching it. And so we don't know whether or not the improvement came because of the alternate curriculum or from the fact that a math specialist is now teaching it. And so there's some confounding there, and there's no way to know really, well, maybe we should just be hiring math specialists, or maybe we just need to have everyone do the alternate curriculum and then see what happens. Second, a drug company study about a weight loss pill reports that people lost an average of 8 pounds while using their new drug. However, in the fine print, you find a statement saying that participants were encouraged to also diet and exercise. And so here, the possibilities are it could be this new drug, okay, a weight loss pill, or maybe it was the diet, or maybe it was the exercise that they did. And so who knows? Maybe this weight loss pill doesn't do anything. Maybe it's even worse. Maybe people dieting and exercising actually would have lost more if they hadn't been taking the pill. And so this is confounding because there's no way to know what was the true cause of this weight loss, and to what degree did each thing affect that outcome. All right, and third, we've got researchers conduct an experiment to determine whether students will perform better on an arithmetic test if they listen to music during the test. They first give the student a test without music, and then give a similar test while the student listens to music. So this is actually kind of pretty common, actually, that people make this big mistake. And that is that they're having these students take two similar tests. And so we don't know, we take a test and then we take a similar test. Well, maybe the result was skewed because the student saw questions that they were then able to figure out the second time because they kind of knew what was coming. Or maybe they got bored because they were doing the same thing, and so they did worse. Who knows? There's no way of knowing if the music had an effect or the fact that they were doing similar tests. So a big thing that people do when they're designing studies is figuring out how to reduce confounding, and the most common way is through what's called a control group. And a control group is where you have your individuals participating in the experiment, and you have a control group, a group that just kind of goes about things as normal and doesn't receive the treatment that you're actually administering. And then you've got the treatment group that actually gets the treatments. And then you can measure and you can compare and see what the differences are. And that helps you to identify what effect the treatment had, since you can compare it against the control group. So let's look at an example. To determine if a 2-day prep course would help high school students improve their scores on the SAT test, a group of students was randomly divided into 2 subgroups. The first group was given a 2-day prep course. The second group was not given the prep course. Afterwards, both groups were given the SAT. So this is where we're using a control group. We've got our treatment group is the people that are the group getting the 2-day prep course, and the control group is the group that does not get it. Okay, just the as normal group. And then they both take the ACT so that we can measure and see what happens and compare the two. All right. So our control group here was the 2-day prep course. The control group was the ones that did not have the prep course, and the treatment group was the 2-day prep course. Here we've got a company testing a new plant food grows 2 crops of plants in adjacent fields, one group receiving the new plant food and the other group not. The crop yield would then be compared. So by growing them at the same time in the adjacent fields, it's got the same area, kind of same temperature, same weather, okay, all that stuff. So we've got the control group, which is the one that doesn't get the new plant food, and the treatment group, which does get the new plant food. And these groups are as similar as possible, and the only difference that we're really aware of is the type of food that they're getting, and that helps us to compare the effect. One thing that is important to be aware of is something called the placebo effect. And this is where a treatment can actually have an effect on an individual just because the individual thinks that they're receiving treatment. Okay, so the effect of a treatment is influenced by the patient's perception of how effective they think the treatment will be. And so that's called the placebo effect, and it's a real thing, in that people that just the fact that they know they're receiving treatment can affect the outcome. So placebos are very commonly used. A placebo is a dummy treatment that's given to the control group, so that the control group thinks that they're being given a treatment, and that reduces the confounding effect of thinking that you're receiving a treatment or not. And so when we have a placebo, we call it a placebo-controlled experiment. And so we've got our control group and our treatment group. And if the control group receives the placebo and the treatment group receives the actual treatment, everyone thinks that they're receiving the treatment. And so that will reduce any confounding based on just knowledge that you're receiving a treatment. So let's look at some examples here. A medicine study is testing a new headache pill by giving the treatment group the pill and the control group nothing. If the treatment group showed improvement, we wouldn't know if it was just because they received a pill or if it was because the pill itself was actually useful. Okay, it could be that they thought they received a headache treatment, and so in their mind, oh yeah, it's getting better. Okay, and so to fix that with a placebo, you could give everyone a pill. You could give the control group some saltwater pill or whatever, something that doesn't actually have any effect, and then the treatment group give the new pill, and then you could actually compare. For second, we've got in a study for a new medicine that is dispensed in a pill form, a sugar pill would be then used as a placebo. Okay. Third, in a study on the effect of alcohol on memory, a non-alcoholic beer might be given to the control group as a placebo. So they are thinking they're drinking beer. They think, oh, I'm getting my alcohol, and those that are receiving regular alcohol, then they wouldn't know, and so the researcher could then compare the outcomes and not be worried about the effects being confounded. Next, in a study of a frozen meal diet plan, the treatment group would receive the diet food, and the control group could be given standard frozen meals stripped of their original packaging. And so the people receiving the food wouldn't know if they're on a specific diet plan or if it's just a regular, they would just think, oh yeah, I'm on a diet now. And that could affect, of course, the outcome if people knew that they were on a diet versus not. Last, we've got a study found that when doing painful dental tooth extractions, patients told they were receiving a strong painkiller while actually receiving a saltwater injection found as much pain relief as patients receiving a dose of morphine. So here we've got the placebo is the saltwater injection, and the morphine is the actual treatment. And the confounding effect of knowing that you're receiving a treatment was removed. Another technique that is used to remove some confounding is something called blinding. And a blind study is when the participant does not know what they're receiving. Okay, so if they're receiving a treatment versus a placebo, you obviously don't want the individuals to know that they're receiving a placebo because that's going to affect the outcome, their perception. But a little bit further than that, we have things called double-blind studies. And a double-blind study is where a researcher that's actually interacting with the participants doesn't actually know what the participant is receiving, whether or not it's the actual treatment or if it's a placebo. And so obviously there's got to be some record. And so the person in charge of the study would know, okay, we've got our control group and our placebo group and our treatment group. But the person actually administering the treatments, maybe giving them the pill or whatever, doesn't actually know what type of pill each person is receiving. And that would remove a little bit of effect that maybe the person interacting with the participant might change how they're behaving if they're giving a placebo to someone. Or maybe will change their diligence in recording outcomes and effects if they know that someone has a treatment or a placebo. And so a double blind is a powerful technique to remove that bias that can arise in an individual's mind that's actually administering the treatments. Let's look at some examples. In a study about antidepressant medicine, you would not want the psychological evaluator to know whether the patient is in the treatment or control group because it might influence their evaluation. And so you would do a double-blind study so the evaluator just thinks, okay, well, everyone got a treatment. And they don't know what each person received. Next, if a researcher is testing whether a new fabric can withstand fire, she would just need to torch multiple samples of the fabric. There wouldn't be need for a control group, right? So no control group, no blinding or anything, because all you need to do is see the effect. So blinding is not always necessary, nor is a control group always necessary. You need to decide based on your actual study. Third, to test a new lie detector, 2 groups of subjects are given the new test. One group is asked to answer all the questions truthfully, and the second group is asked to lie on one set of questions. The person administering the lie detector does not know what group each subject is in. So this is a double-blind study because the person that's administering the lie detector test doesn't know what people are doing. Okay, and because if they did, then they would be more attentive, looking for the lies, and we of course don't want that. That would introduce some confounding.